In this class, your project is to build a simulation using the concepts you've learned. As examples, you'll be building an ice cream truck managing orders and a minimal model of light switches in a home. Your simulation could be for anything: a bike shop processing repairs, a warehouse processing bulk shipments, or an air traffic controller managing aircraft. Pick whatever scenario you want. Just make sure that your scenario has many different types of interacting objects. The simulation you build is powerful. In the future, you can add an interface to make it a management app. Use this system to predict the future for a very complex system, or build a game with it. In this class, we won't cover the bells and whistles, for example, how to add an interface. Instead, we'll focus on the core, an interacting series of objects, and how to make that code flexible, scalable, and maintainable. This is a great way to understand the power of object-oriented programming and how to use it effectively. As you may have heard from one of my previous classes, my motto is to give you the excitement to learn more, not necessarily hand you laundry lists of different Python utilities. The same applies in this class, but here, I also want to give you the intuition for writing better, cleaner code. To do that, we'll code up each concept, not once, but twice. We'll do this specifically in 4 different phases. First, we'll cover the OOP paradigm, the philosophy and foundation of object-oriented programming. Second, inheritance, ways to make OOP less redundant, improving maintainability. And finally, Nixons and composition, ways to make OOP easily extensible and flexible. As we practice each of these concepts, I want you to get a feel of what is wrong and what is right in designing code. Forgetting these exact terms and definitions won't make much of a difference. What you want is the intuition for writing cleaner, better code. Each of the 4 phases is split up into 3 different parts. The first part is the concept, introducing the ideas, terms, and definitions. The second is practice. You will then use these concepts in 2 different examples. Some phases will be accompanied by a mystery lesson. This mystery lesson covers a special OOP concept. These mysteries are actual bugs that students have encountered before. I hope that these lessons can save you some pain and confusion in the future. You may have heard of other OOP concepts like polymorphism or encapsulation. I'll mention these terms briefly, but not in detail, as I believe that the core of OOP lies with the terms that we will cover: abstraction, inheritance, Nixons, and composition. There are a large number of lessons, but I've designed each lesson to be relatively short and bite-sized so that you can hopefully take each of these lessons on the go, on your commute, on a bathroom break, anytime really. I hope you're excited to start building your simulation. Let's get started.